Astronomy is more than just a science. It's a journey of discovery. For centuries, humans have looked up at the night sky. They wondered about the stars. They questioned our place in the universe. This quest for knowledge has driven us to explore the cosmos. We have made incredible discoveries along the way. Our journey begins in the 16th century with Nicholas Copernicus. He was a Polish astronomer who challenged the prevailing view of the universe. Copernicus posited that the Sun, not Earth, was the center of the universe. This heliocentric model was a revolutionary concept. The late 16th and early 17th centuries witnessed a scientific revolution led by the Italian astronomer and physicist Galileo Galilei. Galileo's contributions to astronomy were transformative. He was among the first to use the telescope to observe the heavens. His observations supported Copernicus's heliocentric model. Galileo's telescope allowed unprecedented clarity. He observed the moon's cratered surface. He discovered 4 moons orbiting Jupiter. While Galileo's observations supported the heliocentric model, Johannes Kepler refined Copernicus's ideas, describing planetary motion. Kepler discovered planets move in elliptical paths, not perfect circles. He formulated 3 laws of planetary motion. These laws provided a mathematical framework for celestial movements. The 18th century witnessed a deepening understanding of celestial mechanics, fueled by Isaac Newton's groundbreaking work on gravitation. Edmund Halley, an English astronomer, applied Newton's laws to comets. Comets became objects of scientific inquiry. Halley realized a comet observed in 1531, 1607 and 1682 was the same. He predicted its return in 1758 using Newton's laws. This marked a watershed moment in astronomy. For centuries, the solar system was thought to end at Saturn, the farthest planet visible to the naked eye. In 1781, William Herschel discovered Uranus, changing our view of the solar system. Herschel found a faint disk-like object, unlike stars. Initially thought to be a comet, it moved in a regular orbit around the Sun. Calculations showed it lay beyond Saturn, revealing a 7th planet. As astronomers explored the solar system, a new class of celestial objects emerged. Between Mars and Jupiter, a vast gap existed. On January 1st, 1801, Giuseppe Piazzi made a remarkable discovery in Taurus. He noticed a faint object moving against the stars. Mathematician Carl Friedrich Gauss calculated its circular orbit around the Sun. It was the first asteroid, a minor planet, to be discovered. While telescopes revealed new planets and objects, James Clerk Maxwell unified electricity, magnetism and light into Maxwell's equations. These equations predicted electromagnetic waves traveling at the speed of light. These waves include radio waves, microwaves, infrared, visible light, ultraviolet, X-rays and gamma rays. As the 20th century dawned, a revolution in physics was brewing. Albert Einstein published his theory of special relativity in 1905, challenging the classical Newtonian view of space and time. His famous equation E equals mc squared established that energy and mass are equivalent. Special relativity had profound implications for our understanding of the universe. It predicted phenomena such as time dilation and length contraction. These predictions were later confirmed by experiments. In 1915, Einstein revolutionized our understanding of gravity with his theory of general relativity. General relativity describes gravity as a curvature of space-time caused by mass and energy. While Einstein reshaped our understanding of the universe, astronomers mapped our galaxy, the Milky Way. The Milky Way, a hazy band of light, fascinated many. Harlow Shapley made groundbreaking contributions to understanding its structure. He studied globular clusters using Cepheid variables to measure distances. Shapley estimated the Milky Way's size and our position within it. While astronomers made groundbreaking discoveries, a revolution in rocketry was taking place, enabling us to venture into space. Robert H. Goddard, the father of modern rocketry, pioneered liquid-fueled rockets. Solid-fueled rockets were difficult to control. Liquid-fueled rockets could be throttled and restarted, achieving higher altitudes and longer flights. As astronomers explored the outer solar system, an anomaly in Uranus's orbit hinted at another world beyond Neptune. Percival Lowell believed an unseen planet X was affecting Uranus's orbit. He founded Lowell Observatory in 1894 to find this world. Lowell calculated Planet X's position but died in 1916 without success. In 1930, Clyde Tombaugh discovered Pluto while comparing photographic plates. During World War II, a technological marvel emerged, forever altering human history and ushering in the space age. In Nazi Germany, Werner von Braun and his team developed the V2 rocket, a giant leap in rocket technology. The V2, short for Vergeltungswaffe 2, was the first liquid-fueled ballistic missile. It stood over 45 feet tall and weighed over 12 tons. Fueled by liquid oxygen and alcohol, it generated 56,000 pounds of thrust. The year 1957 marked a pivotal moment in human history, the dawn of the space age. On October 4th, the Soviet Union launched Sputnik 1, the world's first artificial satellite. This small metallic sphere transmitted radio signals as it circled the globe. Sputnik, meaning fellow traveler in Russian, captured the world's attention. The launch sent shockwaves through the United States. In response to the Soviet Union's early lead in the space race, on July 29, 1958, President Eisenhower signed the National Aeronautics and Space Act, officially establishing NASA. This marked a turning point in the US commitment to space exploration. The early years of the space race were characterized by a series of dramatic firsts as the Soviet Union and the United States vied for supremacy in space. Just 3 years after the launch of Sputnik 1, the Soviet Union achieved another groundbreaking milestone, the first human-made object to reach the surface of the Moon. On September 14, 1959, the Soviet Luna 2 spacecraft, launched atop a powerful Luna 8 K-72 rocket, successfully impacted the Moon's surface. The spacecraft, a spherical probe equipped with scientific instruments, made a direct hit near the western edge of the Mare Imbrium, also known as the Sea of Rains. The early 1960s witnessed a dramatic escalation in the space race as both the Soviet Union and the United States set their sights on the ultimate prize, putting a human into space. The Soviets, building on their early successes with Sputnik and Luna, achieved this historic milestone first, marking a watershed moment in human history. On April 12, 1961, Yuri Gagarin, a young Soviet cosmonaut, became the first human to journey into space. Aboard the Vostok 1 spacecraft, Gagarin completed a single orbit of Earth, lasting 108 minutes before returning safely to Earth. The Soviet Union's success in launching Yuri Gagarin into space galvanized the United States, intensifying the pressure on NASA. On May 5, 1961, Alan Shepard became the first American in space. Shepard's flight was a significant achievement, but it paled in comparison to Gagarin's full orbit of Earth. On February 20, 1962, John Glenn became the first American to orbit Earth. In a bold move, President John F. Kennedy, in a speech to Congress on May 25, 1961, challenged the United States to land a man on the Moon and return him safely to Earth before the end of the decade. This ambitious goal galvanized NASA and the nation, setting in motion a monumental effort that would test the limits of human ingenuity. NASA worked tirelessly, developing the massive Saturn V rocket, the Apollo spacecraft, and the lunar lander, all essential components for a successful lunar landing. On July 20, 1969, the world watched as Apollo 11, crewed by Neil Armstrong, Buzz Aldrin, and Michael Collins, achieved Kennedy's challenge, landing the first humans on the Moon. Armstrong's words, "That's one small step for man, one giant leap for mankind," marked a pivotal moment in human history. While the race to the moon captured the world's imagination during the 1960s, both the Soviet Union and the United States recognized the need for a sustained human presence in space. On April 19, 1971, the Soviet Union launched Salyut 1, the world's first space station. This cylindrical outpost provided a habitat for cosmonauts to conduct experiments and monitor Earth. While the Soviet Union celebrated its success with Salyut 1, the United States was facing a different set of challenges. The Apollo program, having achieved its goal of landing humans on the moon, was winding down, and NASA was seeking a new direction for its human spaceflight program. Space stations, with their promise of long-duration missions and diverse research opportunities, presented an appealing next step. On May 14, 1973, NASA launched Skylab, the United States' first space station. Skylab, assembled from a modified Saturn V rocket stage, was significantly larger and more spacious than Salyut 1, offering a more comfortable and versatile habitat for astronauts. In the realm of robotic exploration, the late 1970s witnessed an unprecedented mission of discovery, a grand tour of the outer solar system. NASA's Voyager program, consisting of two identical spacecraft, Voyager 1 and Voyager 2, embarked on a journey that would forever change our understanding of the giant planets and their moons, revealing a breathtaking tapestry of celestial wonders. Launched in 1977, Voyager 2, taking advantage of a rare planetary alignment, set course for a grand tour of the outer solar system, visiting Jupiter, Saturn, Uranus and Neptune, while Voyager 1, on a faster trajectory, focused on Jupiter and Saturn. Mars, the enigmatic red planet, beckoned with its promise of holding clues to the history of our solar system and the potential for past or even present life. NASA embarked on a series of ambitious robotic missions to explore Mars in greater detail, deploying rovers to traverse the planet's surface, analyze its geology, and search for signs of ancient water. In 2004, NASA's twin rovers, Spirit and Opportunity, began one of the most successful robotic exploration missions in history. Designed for 90-day missions, these resilient rovers far exceeded expectations, sending back a treasure trove of data and stunning images. While government agencies like NASA had long dominated space exploration, the 21st century saw a dramatic shift, with private companies commercializing space travel. This new era, driven by innovation and entrepreneurial spirit, promised to revolutionize space travel. SpaceX, founded by Elon Musk in 2002, emerged as a leader in commercial spaceflight, developing reusable rockets to reduce launch costs. For 3 decades, NASA's space shuttle program symbolized human ingenuity and the quest to explore space. These reusable spacecraft ferried astronauts, deployed satellites, and assembled the International Space Station. As the shuttle fleet aged, NASA retired the program, ushering in a new era in spaceflight. The final mission, STS-135, concluded in July 2011, marking the end of an era. NASA now relies on Russia's Soyuz while developing new spacecraft for future missions. The 21st century has witnessed a resurgence in space exploration, driven by technological advancements and international collaborations. This new space age, characterized by ambitious missions and groundbreaking discoveries, promises to reshape our understanding of the universe. Our journey through the annals of astronomy has taken us from the revolutionary ideas of Copernicus to the awe-inspiring achievements of the space age. Each generation has built upon the discoveries of those who came before, pushing the boundaries of human understanding ever further. These milestones stand as testaments to our ingenuity and courage. As we've explored the cosmos, we've learned more about our own planet, a pale blue dot suspended in the vastness of space. The future of space exploration seems limitless. With the James Webb Space Telescope unlocking secrets, the Artemis program aims to return humans to the moon. Crewed missions to Mars are on the horizon. Commercial spaceflight is making space more accessible. New opportunities for research and tourism are emerging. The future requires technological innovation and cooperation. The ISS serves as a model for future endeavors. The next chapter promises to be awe-inspiring. The stars beckon